All right, so from our last video, we said that if we are given BJT fixed biasing, like this one, let's say we have so we said that if you are given something like this one, we can transform it to the following structure. Okay, so we can have the following two circuits. Like this one will be representing the input signals, and this one will be representing the output signal. So from here, we said that it's to be very easy to apply a KVL, which would be like VCC minus IBRB minus VBE equals to 0. So from here we get IB equals to VCC minus VBE over RB. Then from the output, we can have VCC minus ICRC minus VCE equals to 0. So here we can get VCE, which is a collector emitter voltage, equals to VCC minus ICRC. So from here, no problem. For example, we are given the following circuit and the following data, like VCC equals to 8 RB 360 kilo, RC 2 kilo, and beta equals to 100. We are being asked to find the following: VB, IB, IC, and VC. Okay. So for my equation here above, we can see that we can start with part B, which will be IB, the base current, equals to VCC minus VBE over RB, which equals to 8 minus 0.7 over RB, which is 360 kilo. So from there, I can see that IB equals to 7.3 over 360 kilo. This will give 20.3 microamps. So we have already calculated part B. So from there, we can calculate part C, which says we know that IC equals to beta times IB, which will be 100, because we are given the beta of 100 times 20.3 microamps. This will give IC equals to 2.3 milliamps. So I've already have the part C. Part A, we know that we are being asked for this voltage here. Okay, and part C, we are being asked for this voltage here. So if we go back to part A, we know that VBE equals to VB minus VE. As we know here, VE is connected to the ground here. So VE equals to 0. This is to say VB equals to VBE, which equals to 0.7 volts. Lastly, if we go to part B, We also know that VCE equals to VC minus VE. Again, we are using this reasoning here. This gives us VC equals to VCE, which is, from this equation here, we can calculate VCE, which equals to VCC minus ICRC. So we have IC, we have RC, we have VCC. This would be equals to, I realized I made some mistakes, so I had to remove a part of the video. Okay. So this would be VCC, which is 8 volts times, minus ICRC. We already had IC calculated here, and RC was given as data right here. So from there we have 8 minus 4.6, which equals to 3.4 volts. So from this point to this point will be 3.4 volts. Thank you.